Welcome to lesson number 2 of Trig. We're going to be looking at the sine law. Now, the big thing with the sine law is we're now looking at triangles that are not 90-degree triangles or right triangles. So now we're looking at triangles that have angles that have an angle greater than 90 degrees. And so in Trig, with these types of triangles, we use a different notation. So if I have triangle ABC, we have the length that is the opposite side of angle A. So if this is angle A here, the side opposite, we would call A rather than side CB. If I have the length of the side opposite of angle B, which is right here, I would refer to that as side B rather than side AC. And then if I have the side opposite of angle C, I would refer to that as side C instead of side AB or BA. So what the sine law says that in every triangle ABC, the ratio of A to sine A is equal to the ratio of B to sine B, which is equal to the ratio of C to sine C. Or we could say that that ratio is equal to sine A over A, which is equal to sine B over B, which is equal to sine C over C. All right, so either way, we can refer to the sine law in terms of the ratios of all the sides to their sine of their angles. So if we're looking to look at a proof of the sine law right here, then the diagrams show the same triangle. So ABC is placed with AB on the x-axis, and in the origin is at A, and then in the second diagram here, the origin is at B. And the line CD is drawn perpendicular to AB. So here's side AB, CD goes up, and same thing over here, it's just flipped. What we want to do is complete the following work to show that the ratio of A to sine A is equal to the ratio of B to sine B. And so if I look at side CD with that 90-degree triangle, we could say that side CD is equal to B sine of B, or sorry, B of sine A. And the reason we could say that is because this is here's a 90-degree triangle, and if I'm referring to B and sine A, then B is my hypotenuse, and CD would be the opposite side. So CD is equal to B sine A. And then if I look at sine B, we could say sine B here is equal to opposite over hypotenuse. So the opposite side of this angle is going to be this side, CD, over the hypotenuse, which is BC, which is equal to CD over A. Then CD, we could rearrange this to say, well, CD then is equal to A times sine B. And so then it would make sense that B times sine A is equal to A times sine B. And if we divide both of those by sine A and sine B, that would give us B over sine B is equal to A over sine of A. Okay, now let's look at how we actually use the sine law. So here I have example number 2, and this is the triangle from class example number 1 where you're just using SOHCAHTOA. And what I want you to do is make sure that you do that example on your own using the primary trig ratio SOHCAHTOA. But in this method, we're going to look at using the sine law to solve the length of BC, which is right here, which we could also call side A. And so the first thing I want to do is I'm going to write the notation that we would use for sine law. And so this side here would be opposite of B, would be side B, and 12.5 centimeters would be side C. Now, what I'm trying to solve is the length BC, which is also A. Now, if that's what I have, to use the sine law, we need to know 3 pieces of information. So this information must include both numerator and denominator of one of the 3 fractions, and it also needs to include either an angle or a side of one of the unknowns. So here I'm looking for the side length of A, and I have sine A here. And so if this is my unknown, then I'm going to write my unknown is A over sine A. And that equals the ratio of one of my knowns. And one of my knowns is sine C and side C. So that would give me the statement A over sine A is equal to C over sine of C. Now I fill in my knowns, so I don't know what this is, A, but I do know what sine A is, and that's sine 75 degrees. And I know what C is, that's 12.50, and sine C is 35 degrees. Now, in order to rearrange this, we need to isolate this A variable. And in order to isolate A, I would multiply both sides by sine 75, bringing it to this side. So this would be 12.50 times sine 75 degrees divided by sine 35 degrees. Now, when you're calculating these, you make sure that your calculator is in degrees rather than radians. And so we're in degrees, good. Now we can determine what this value is. So I'm going to type in 12.5 times sine 75. And then I'm going to divide that by the sine of 35. And I get a value of 21.05. 21.05, and that's centimeters. And that would be my final answer. Now, example number 2, we want to use the sine law to determine this triangle here. So I use the sine law in the triangle shown to determine the measure of angle ACB. So angle ACB, and that's this one here, to the nearest degree. Now, what do we have? Well, first of all, I have to label. I have side C, I have side B, and I have side A. So I don't have anything for side C, which if you don't have anything, what we're going to need to determine is what are some of my unknown variables. So what I could determine is what this angle is, which would then tell me what this angle is. Now, in order to find out what side B or what angle B is, I need to use I can't use any of my components of my C or side C, so I have to set this up using A's and B's. So A sine A is equal to B sine B. My value of A is 9.4 over sine 110 degrees, and my value of B is 6 over sine B. That's my unknown. Now, in order to determine what this value is, we have to rearrange. So in order to rearrange, I'm going to have to get this sine B by itself. So I got to isolate that. I'll have to bring that sine 110 up, multiplied by 6, and then divide by 9.4. So as I rearrange, sine B is going to equal 6 times sine 110 degrees divided by 9.4. This gives us a value of, well, 6 times sine 110 divided by 9.4 is 0.599. Now that's just the ratio for sine B. So 0.599 0.98 is the ratio. Remember, in order to find the actual angle, we need to take the inverse of this ratio. And so the inverse sine of this ratio is 36.8 degrees. Now, remember, all angles in a triangle add up to be 180 degrees. So that means angle C right here is going to equal 180 degrees, subtract 10, subtract 36.8 degrees. And my angle C is going to equal 33 degrees to the nearest degree. Okay, this last question is very similar to the one above, and so the first thing it tells us is what all the measurements are. So I'm going to help you set it up, and then this is one that I want you to work on your own, and then we'll look at it in class tomorrow. So the first thing we're told is a surveyor measures a baseline of PQ to be 440 meters. So we know that from P to Q is 440 meters. He takes measurements of a landmark R, so this landmark R from P and Q, and finds that angle QPR is equal to 46 degrees. And PQR is 75 degrees. Calculate the perimeter of PQR, so the distance around this triangle to the nearest meter. Now, one thing you're going to have to do is determine what this unknown angle is. And you're also going to have to find out what Q is, as well as what P is equal to. So P and Q, you have 440, and you can determine the rest.